His name is Ray Jayawardana. I told you I was going to screw it up. Ray Jayawardana, who is a planet hunter at the University of Toronto. Ray J, as he is known, is the author of the 2012 book, Strange New Worlds, The Search for Alien Planets and Life Beyond Our Solar System. He has an upcoming book coming out just in time for Christmas. It hits shelves in December. It is called Neutrino Hunters, The Thrilling Chase for a Ghostly Particle to Unlock the Secrets of the Universe. Christmas gifts. Very good idea. Good. You know, you'll be the hit of the party at Christmas if you give a book like that, right? They'll say, what is this about? You say, you have to read it. I saw this guy in Hamilton speaking. Ray says what matters now is the question, is there life on other worlds? Please help me welcome Ray Jayawardana.
Thanks, Pia. I'm just going to wait a second to hopefully get the slides up here. Good evening, everybody. So my question for tonight is one that's been an age-old question. There we go. It's easy to forget now that just 20 years ago, we knew of only one planetary system. And that planetary system had 9 planets. Remember that? Wasn't so long ago. And then, in the intervening years, we astronomers managed to lose, or at least demote one, which made quite a few people very unhappy. School children wrote us letters calling us heartless or worse. Cartoonists had a field day. And there was at least one protest march that I know of in New Mexico. And 4 state houses in the US passed unanimous resolutions declaring that Pluto shall remain a planet. What do these astronomers know? But in the midst of all this commotion, we've actually gained many, many new planets. In fact, after centuries of speculation, decades of false starts, now we know of scores of other planetary systems circling other suns. And this is truly a revolution in our understanding of planets beyond the shores of our own planetary system, and understanding how they came to be, what they're made of, how they compare to our own. In fact, thanks to searchers with telescopes on the ground and in space, as of today, we have 1,000 confirmed planets circling other suns. 1,000 confirmed planets. That just happened this month. Plus another 2,500 planet candidates discovered by, in particular, this Kepler spacecraft, which was staring at a little patch of the sky for 4 years continuously before it had some technical difficulties a couple of months ago. With all of these thousands, literally thousands of worlds that we're discovering beyond the shores of our solar system, we're beginning to get a sense of how we stack up. In particular, among these thousands of candidate planets that Kepler has discovered, a handful are starting to look a little bit like the Earth in that they're about the same size as our planet. A few dozen of them appear to be at the right distance from their stars, such that they're not too hot and not too cold. They could sustain liquid water on their surface. In other words, we have a few dozen planet candidates now that, in principle, could harbor life as we know it right here on Earth. At least in a few of these cases, in a few of the cases of extrasolar planets, as we call them, planets that circle other suns, we can learn something about what they're made of, their atmospheres, and even their climate by, for example, tracing the changing phases of the planet as it goes around its star. Just like we see the phases of the moon, we can measure the light changing as different parts of the planet get illuminated as it travels around its own star. And in some cases, we can also take crude spectra of the planet. This looks like one big mess. Using a whole series of telescopes on Earth and in space, we're able to make measurements of what the atmosphere of these planets are made of. And that tells us, hopefully someday, whether those planets harbor the right kind of chemistry to support life. The kind of spectrum that we hope to take in the near future is something like this. What we're looking at here is a spectrum actually of our own planet, the Earth, as reflected on the dark bit of the moon. When you look at the moon, you see a crescent moon, and the rest of the moon isn't completely dark because Earth light, reflected sunlight from the Earth, is falling on the moon. We call this Earth shine. So by taking a spectrum of this bit of the moon, we can actually see our own planet in reflection. And when you look at the spectrum, what you see are all these molecules like water, oxygen, carbon dioxide, methane, ozone, these molecules that we tend to call biosignatures or indicators of life. So the hope is that someday we could point our telescopes at a planet circling another star and measure the presence of these kinds of molecules. And if several of these biosignatures are present at the same time on the same planet, that might tell us there is life on it. The problem, of course, is that even if you had all these biosignatures detected, you still wouldn't know whether you're looking at a planet full of slime or civilization. That's a big challenge. Unless, of course, we happen to detect artificial radio signals coming from the same planet, then we would know not only is there life, there might be life with technology. That might make a huge difference. Even if we can't decode the message that is in the radio signal, just the fact that there's somebody at the other end, a messenger sending it out, will tell us a lot. It would be interesting to think how we would react, how people would react to the realization, to the first compelling evidence, not just speculation, but true compelling evidence that we are not alone in the universe. It's indeed a big question, and we don't really know till it happens, but it might not be that far in the future. It's worth considering. So I just want to wrap up by saying that we truly are witnessing an unfolding revolution in our understanding of our own place in the universe. It's not an exaggeration to say that this moment in history is not that different from when Galileo turned his telescope at the heavens for the first time 400 years ago. In particular, when he pointed at Jupiter and saw 4 little dots, the 4 biggest moons of Jupiter, and he could track them night after night and show that these 4 moons circled Jupiter, they orbited Jupiter. There was compelling evidence for the first time that not everything in the universe revolved around the Earth. That was a dramatic realization. And the kind of discoveries that are coming through the pipeline right now are completing that understanding, are helping us truly understand how we measure up, how we stack up, how our solar system compares to others, and also whether we are alone in the vastness of the universe. Thank you.